Imagine you're floating in space and you slip past a point of no return. No alarm goes off. Nothing feels different. But you've just crossed a line that nothing in the universe, not even light, has ever come back from. Today we're taking that fall ourselves. We're diving straight into a black hole step by step, from the moment you cross the edge to whatever waits at the very center. And what happens along the way is far weirder than you probably think. First, quick refresher. A black hole is what's left when a truly massive star, many times bigger than our sun, runs out of fuel and collapses in on itself. With nothing left to push back against gravity, all that mass gets crushed into an unbelievably tiny point called a singularity. The gravity around it becomes so intense that there's an invisible boundary, the event horizon, where escape becomes impossible. Cross it, and you're not coming back. Not with rockets, not at light speed, not ever. It's the ultimate one-way door in the universe. Okay, deep breath. Suit sealed, cameras rolling, no turning back. Let's cross it. Here's the first surprise. Crossing the event horizon feels like nothing. There's no wall, no flash, no warning sign. If the black hole is big enough, like the supermassive ones sitting at the centers of galaxies, you could drift right past the point of no return without even noticing that anything happened at all. But look back over your shoulder. The universe behind you is doing something strange. Because of how the black hole bends light, the stars appear warped and distorted, squeezed into a shrinking circle of light above you, like looking up at the surface from the bottom of a swimming pool. That circle is the entire visible universe, packed into a single window that's slowly closing. Time is getting weird too. To your friends watching from a safe distance, you appear to slow down and down until you seem completely frozen at the horizon, fading away like a ghost. They never actually see you fall in. But here's the strange part. For you, time feels totally normal. Your watch ticks like it always has. You keep falling. Enjoy the view while it lasts, because now comes the bad news. As you get closer to the center, gravity doesn't pull on you evenly. It pulls way harder on your feet than on your head, simply because your feet are closer to the singularity. At first, it's a gentle tug, then it's a stretch. Then the difference becomes so extreme that your whole body would be pulled out like a noodle. Scientists literally call this spaghettification. That's the actual scientific term, published in real physics papers. Someone got paid to name it that. Here's the twist, though. The size of the black hole matters a lot. Fall into a small one, say a few times the mass of the sun, and you get spaghettified before you even reach the event horizon. But fall into a supermassive black hole, millions or even billions of times the mass of the sun, and the stretching happens much deeper inside. You'd survive the crossing. For a while. Maybe hours in the biggest ones. So what's waiting at the middle? Honestly, we don't know. The singularity is where our math simply breaks down. Einstein's equations, the very same ones that predicted black holes in the first place, just stop giving sensible answers. It's like asking a calculator to divide by zero. The universe's own rulebook simply runs out of pages at the exact moment things get interesting. Some physicists think singularities aren't even real, and that a deeper theory of physics, one that combines gravity with quantum mechanics, will eventually replace them with something else entirely. Others have proposed genuinely wild ideas, black holes connecting to other regions of space, or all the information about everything that ever fell in being preserved on the horizon like a hologram. These aren't science fiction plots, they're open questions that real scientists argue about today at conferences on whiteboards right now. Which means the inside of a black hole is one of the last true mysteries left in the universe. We've mapped the ocean floor. We've landed robots on other planets. We've photographed the faint glow left over from the birth of the universe itself. But past that horizon? Total unknown. No probe, no telescope, no equation can bring back the answer. One more mind-bending thing before we zoom out. Black holes might not even be forever. Stephen Hawking discovered that black holes should slowly leak energy, a faint glow now called Hawking radiation. Over unimaginable stretches of time, far longer than the current age of the universe, A black hole could evaporate completely, shrinking bit by bit until it vanishes in a final flash. So the most permanent-seeming objects in the cosmos may actually have an expiration date, and in case you're wondering, no, we haven't just imagined all of this. In 2019, astronomers released the first real photograph of a black hole's shadow, a glowing orange ring around a dark center, captured by linking radio telescopes across the entire planet into one Earth-sized camera. We've also detected the ripples in space itself, gravitational waves, created when two black holes slam into each other and merge. Black holes are not a theory anymore. They're out there, and we're watching them. So let's recap. Falling into a black hole means crossing an invisible line without noticing, watching the entire universe distort into a shrinking circle behind you, getting stretched into a cosmic noodle, and ending up somewhere physics can't yet explain. The good news? The nearest known black hole is over 1,500 light-years away. That's so far that even traveling at the speed of light, it would take longer than recorded human history to get there. You're safe. Probably. And honestly, that distance might be the only reason any of us can talk about this so casually. If your brain just got spaghettified by this video, smash that like button and subscribe for more journeys across the cosmos, and comment below, would you ever volunteer to be the very first person to cross an event horizon? Next week, we're covering what happens when the sun dies and what that means for Earth. See you then, space explorers. Stay curious, friends.